Robot is ready. Car is moving. Stopped after 3 seconds.
Now it's waiting for the obstacle.
Warning. Distance 29.97. Making U-turn.
In this lesson, we will see that the robot speaks. And we can play music. Hi.
Welcome to Robojax.
This is SunFounder's PICAR-X Raspberry Pi self-driving robot car kit.
Hello friend, how are you? Turn left here. Count down to 3 seconds. 3, 2, 1, rock. I'm lost.
Once you come to the SunFounder's documentation page, scroll down until you see kits, robot kits, and the first one, PICAR-X Car Kit version 2 with battery. This might change, so you will find this. Click, and on the left side, select Play with Python. And then from here, we can select the lesson that we want. Today, we are going to work with text-to-speech, so click on text-to-speech. This is a simple text-to-speech. The library that is used, this is an open source from eSpeak. If I open it in a new tab, eSpeak text-to-speech, this is very limited in terms of speech. This is not like natural text-to-speech. It's a synthesized text. As you can see here, it says eSpeak uses format synthesis method. This allows many languages to be provided in small size. The speech is clear and can be used at high speed, but it is not as natural or smooth as larger synthesizer which are based on human speech. This is not based on human speech. It works well for our purpose, and there are a lot of pages and documentation and samples that you can learn, and there are a lot of supporting languages. All these languages are supported. You can work in 3 ways with this robot. One way would be to open the PowerShell. If you're on Windows, just click on Start, type POW, and you'll see PowerShell. Run it as administrator. This is the screen. And let's log in. First, let's check if our robot is active. Ping -4. Robojax.local. Our robot responded. Now we can connect using SSH, a secure way to connect SSH, and then username pi@robojax.local, and then the password. So I'm logged in, and from here we can type command. The second way to work is using SunFounder's create agent. I've already installed it, which I've shown it at the early lessons. Click on start menu and type Sun, and you will see SunFounder create agent. Now it's running in the background. If you click on this arrow at the taskbar, you will see it here. Now let's click connect, and we have the IP address. We will type it, username and password, which I explained it at the beginning of the course. Click connect. Now this has been successfully connected, and we see the same command line that we saw in the PowerShell. Let's clear the screen. Here also we can type command. So here is the example code. This is located in PICAR-X example, and the file is called tts example.py. I'm going to put this microphone closer. So I'm going to click on run.
Hello, hi, goodbye, nice to meet you.
And here it read for us, hello, hi, goodbye, and nice to meet you. So the text is printed, and also we heard the sound. Now, when I clicked on this, this has some issue. From here it doesn't work, something is wrong. It prints the text with a lot of delay, and it doesn't read it. So something is wrong here. Click on this text.
Hello, hi, goodbye, nice to meet you.
So it was printed. Now, as you can see, so we have to stop and then run. No, something is wrong with this code. So let's go. Now let's go to CD and then example and dir. I'm going to open this TTS example. Let's wheel mouse backwards, nano TT, and then here is the code. We are importing from robot hat, we are importing TTS, and in this line we are creating a list of words. These are each string separated with comma, enclosed in double quotation. So these are the text. So we have 1, 2, 3, 4, and this square bracket refers to a list, and all of these are stored in a list called words. And then from this class we are creating TTS robot text to speech. So this is text to speech underscore robot object, and then we can use it in our text to read TTS robot dot say. So this is for loop. It starts I in each element of the words is called I, and we print it on the command line on the terminal using I. So this will print hi, hello, goodbye, and nice to meet you. And also the same I, which is element, we send it to this text, to this TTS robot dot say, so it can say it for us. Pressing Ctrl X to exit. Current location, print working directory. So I'm inside Pi home, which is this tilde. This is an alias for that. And in here dir, you will see that we have Robojax. Now let's copy this inside the Robojax. If I do dir Robojax, it shows all the file. I have speak 1, but I'm gonna copy this as speak. So let's do that. cp PICAR-X example and then TTS. This was all autocomplete. I just typed first or 2 letters and then tab. Now we type the destination with 1 space. Robojax and then speak.py. So I'm changing the name to this and copying it. So this file is not touched. Now let's go inside Robojax and dir, and you can see we have speak.py. Here I've changed it. I commented this portion out, and here this line, this will be ignored, and here tts robot.say, and inside the double quotation put your text, and we give it just 1 second until it's said. It will not go to this, so Control O and enter, Control X, exit. Let's run it. Speak.py.
Welcome to Robojax.
Okay, so I will replay it again.
Welcome to Robojax.
As you saw, that was reading the text for us. For more videos, please click on subscribe button or click on the icon on the right side of the screen. Thank you. And here, this is a custom code that I've written. So first it will read some text. After that it will say the robot is moving. It will control the wheels, and then it will read the distance continuously. If the distance is less than 10, and then 3 times it will read it. So continuously it will read. I will not bring any obstacle in front of it, so it will just wait. I will run my hand first time, it will read it, and then second time it will read it, third time, and then it will exit. Let me run the code so you can see it.
Welcome to Robojax. Robot is talking. Car is moving. Stopped after 3 seconds.
Now this is waiting for me, and here
9.92.
that was once,
6.92. 5.6.
and stopped. Now let me explain the code. Nano speak3.py. So this was my file speak1. Let's open it. Nano speak1.py. So this was the main line that already exists, and I added PICAR-X, imported as the PICAR-X from this module, and imported the time. And first I have created an object px, and this is an object for text to speech, and we read text to speech, say welcome to Robojax, and then for 1 second delay, and then robot is talking, and then 1 second delay, and then car is moving, and then px forward with 30% of power, which we have spoken about this in previous lessons, and for 3 seconds wait, and then we apply stop, and then here tts stopped after 3 seconds. So this is done. Now let's go with the arrow. I'm pressing arrow to go down. And here I have created a variable called count, and I set it to 3, and I say while this count is greater than 0, which is true initially, then we read the distance and store the value in the distance variable, and we check if the distance is less than 10, then read it for us, because I didn't want this to continuously read, only less than 10. And then we use this same method, the same method from TTS robot, and we say this distance, whatever is the distance, so it will read it for us. And then once we read it, then we decrement it, count -1. So from 3 we subtract 1, it becomes 2, and the while comes back here, 2 is greater than 0, and then it will come again, compare. If the distance is less than 10, it will read it, otherwise it will just stay. And once it reads it, then now it becomes 1. So 1 will be read, and next time it will be 0. When it comes here, 0 is not greater than 0, it will exit. So the same way you can play with this, and you can, if you see an obstacle, for example, you can stop and say obstacle detected, or maybe turn the steering left or right. Whatever you want, you can do with this. Now I've written this code. I've imported this portion was as before, and here I've set this power, the power 50%, reverse power 30, and then U-turn distance 30. This is a method. I named it turn. So first we turn the steering. When we call this function or method, we turn the steering 40 degrees to the right with 100 millisecond delay, and then we go backward with a power which we defined here for 1 second, and stop and for half a second. So we are back, and then we go forward with 0. We first turn the steering, we straighten the steering at 0 degrees, and then we go forward for 1 second and stop. So every time you call this, it goes back and forth with turning the steering right and straight. This portion is creating an object for PICAR-X, and we call it PX, and this is creating object for text-to-speech robot. And first we say this word, robot is ready, using this same method for 1 second delay after that, and then we put this text, car is moving, and then we go forward with power for 3 seconds, and then we stop. After that we say robot stopped for 3 seconds. After 3 seconds, because we had a delay of 3 seconds. Here we have a counter. The count is 2, so we can do 2 reverse, 0 and 1. That's why I put it. And then this is a while loop that runs up to here. Look, this while is here, and the indent finishes here. So this is all for the while loop. And here we check the distance. If count is greater than 0, then we read the distance. This variable has the distance, and we check if the distance is less than the U-turn distance, which we defined at the top of the code. And here, U-turn distance, then we stop the car because it's less than that distance. And then we read the text. We say warning, distance plus whatever is the distance. We have converted the type to string, so this will read the distance for us. I've commented this out, so this is doing nothing. And then once we do that, we decrement the count. So now 2 is 1, becomes 1. We subtract 1 from it, and then we print this text making U-turn, and we run the turn twice. Depending on the speed, the turn will be different. So I just try twice, we will see it. Else, otherwise, if the distance is safe, it goes forward. So it goes once, and it runs again forward until it sees the obstacle, and it turns again. It does this U-turn. When it becomes become 0, then 0 is not bigger than 0, so this will exit, and we go forward for 3 seconds and then stop. That is the end of the code. This is demonstration on the table.
Robot is ready. Car is moving. Stopped after 3 seconds.
Now it's waiting for the obstacle.
Warning. Distance 29.97. Making U-turn.
So then first U-turn is finished. Now it's going forward until we see
Warning.
obstacle.
Distance 13.04. Making U-turn.
Now it goes forward twice.
I am tired. Stopping.
I'm tired and stopping. Now let's run our own music. I've created a file. I'm going to show you. So nano music.py. I've included from this robot hat. I've imported TTS. That's text to speech and also music. There is some utility. I thought I'm going to need it. And then from this music, I've created music object. As you can see, we don't need TTS because we are not reading any text. And I've created this method. This is a method called horn. And I named it because here we can say music.soundPlay threading and then put the full path to the music. This double horn is located if I do remote desktop inside PICAR-X sounds, and here double horn is located in here. And I wait for 2 seconds and this is playing another sound. Home, pi, download, sample 9 second.wave. If I do the remote desktop inside this downloads, you see 9 second. This did not exist. I downloaded from the internet. Just search for wave file free sample or something, you will get it. This is royalty free. And so this is not doing anything if you don't put this line. So this line is calling this method called horn. So this will run the horn, and let's press Ctrl X to exit, and to run it we will say sudo python music.py. So that's it. This was a demonstration. We can play music or write music notes inside. If we click on this icon, go home, Pi, and then PICAR-X. No, go to robot hat, and then tests. You will see tone underscore test.py. If we look at it, this is a music note that is written. So you just need music, set volume, and from here they have written it. I'm not a music guy, but let me play it for you. I'm inside the test folder in the robot hat. Let's run this one, and I'm going to put the microphone close to the robot. So let's run it. Now let's see how we can run this program when the robot starts. We are going to run this speak underscore floor.py. So first let's open the cron tab or scheduler. That -e means edit. And here, this was my previous cron tab. So it says at reboot. By the way, the cursor was at the top. And by the way, this is the cursor, and we can go with the arrow down. This was my previous cron tab. It says at reboot execute Python 3 of file located in here, for example line inside the Robojax py home, and we are going to change this to speak underscore floor. So spelling must match. When you're done typing, press Ctrl O to write it out and enter, and then Ctrl X to exit. Now let's see, speak floor, the spelling is correct, and we can reboot. Now let's hear it. So this is now rebooting. As you can see, it's blinking. I want to make sure it runs, then I'm going to go on the floor.
Robot is ready. Car is moving.
So I turned it off. The cron tab, the spelling was correct. Thank you for watching. I will see you in the next lesson.